Good afternoon or good evening. Welcome to the ISACA Orange County Talk on Cloud Security. Thanks for joining today. My name is Sunny Suneja, and I'm a senior security architect, senior cloud security architect on McAfee's public sector team. Today, we'll be reviewing the state of the cloud security market from the lens of a CASB. We've got a fair bit of content to unpack over the next 45 minutes. And I'll be doing a high-level demo of the MVISION Cloud CASB platform towards the later part of this presentation. But if you have any questions, we'll definitely be opening up the floor, towards the end of the call. And you can also point out any questions to me or by reaching out to me over LinkedIn or over email. So in terms of a flow here, we'll start off with a high-level overview of CASB and some of its prominent use cases. Then we'll move into some of the architectural nuances that go into place when you're implementing a CASB. And then lastly, we'll touch on how one could go about securing cloud-native applications that may be leveraging containers and managed orchestrators in public cloud environments today. A CASB stands for Cloud Access Security Broker. And if you zero in on the term broker, CASB is basically a cloud-based security policy enforcement point that exists between cloud service consumers on one end and cloud service providers on the other end. Your cloud service consumers could be, identities that belong to your corporate workforce, or those could be identities that belong to your customer ecosystems or to your partner ecosystems. The devices that these consumers access cloud applications with also would basically constitute what is a cloud service consumer. On the other side of the spectrum, your cloud service providers could come in different shapes and forms. These could either be IaaS PaaS-based cloud applications of the likes of AWS, Azure, GCP, or these could be SaaS-based cloud service providers of the likes of O365, Slack, ServiceNow, Box, etc. If you look at the cloud service providers further, there could be certain applications that may have been mandated by your corporate IT, and they may have been blessed by your corporate ID teams for sanctioned use for hosting sensitive data. And then you could also end up having to worry about a lot of cloud applications that may not be inside the purview of your corporate ID teams today. Those could be strictly shadow IT in nature, right? Where where your IT teams have very limited visibility into what data is getting accessed or getting uploaded to these cloud applications, right? Or these could be cloud applications that have been blessed in certain limited functions of your business, but again, they're not being mandated for corporate-wide use just because of the some of the security requirements that these apps may not fulfill at the end of the day. So CASB, in short, helps you consolidate security policy enforcement across all these cloud service providers while keeping the whole conversation agnostic to what your consumers are at the end of the day, right? So if we look at the notion of a CASB, it's definitely evolved over the last decade or so, where in the early formative years, the primary problem definition was to help solve for gaps created by usage of shadow IT applications. Then that evolved to enabling good data protection outcomes in sanctioned SaaS apps. And as companies were moving their private data center applications to public cloud applications, the same controls, the same need for activity monitoring and threat protection kind of evolved to include IaaS and PaaS platforms. And ever since McAfee's acquisition has happened, the data loss prevention teams that have been part of the portfolio for the last decade and a half, and then the software web proxy teams have been working hand in hand with the Sky High product groups to offer what we call the unified cloud edge now. For some of you who may know, the industry is moving towards a SASE-based architecture, which stands for Secure Access Services Edge-based architecture. So by offering the unified cloud edge as a converged platform, including the CASB, DLP, and the software web gateway space, we believe that we are going where the puck is headed in terms of how cloud applications are just a new form factor for how web services were used in the past. So quickly going after some of the cloud adoption and security market trends, a lot of companies out there are actively adopting the cloud. It's very well known at this point that there are certain key drivers to basically that have helped in wide adoption of cloud services. Mostly employees start using personal productivity tools in the beginning outside of corporate IT support to make their lives easier, such as the use of the iCloud, classic Evernotes of the world, and Gmail, etc. Then obviously organizations start to leverage tools for business agility, to be more collaborative, and to speed up the deployment of services by, let's say, moving their CRM to Salesforce, or using collaboration tools like Teams and Slack, etc. Then obviously we're seeing a huge surge in business transformation by companies that want to innovate by creating new apps directly in the cloud. And we've started to hear organizations describe themselves as having a cloud-first charter. So where exactly is sensitive data stored in the cloud? Well, looking at it from a risk mitigation standpoint, most of the sensitive data that actually gets resident in the cloud services gets hosted in cloud services like Office 365, Salesforce, Workday, ServiceNow, and Google. Then the remaining 25% of the data has been increasingly stored in cloud apps like AWS, Azure, GCP. And finally, about 10% of the data gets stored in either permitted or risky shadow IT applications. And while most of the existing security does not cover data, belong to any of these cloud apps, going after the shadow applications first is usually not the best way to go about solving the cloud security needs. What we notice is that employee behaviors are difficult to change over time, require a fair bit of coaching. So especially going after the 10% of the sensitive data out there, it just is counterproductive or counterintuitive, because the maximum bang for the buck for a cloud security program can be found if you were to double up on controls offered by some of these sanctioned cloud applications. There have been some typical problems with regards to security engineering in the last 20 years. No longer is the premise of a perimeter applicable in our day-to-day use. And secondly, in terms of cloud workloads and the kind of applications that get written, we are moving increasingly from a world where there were stateful applications to stateless applications. In the traditional world, the security teams would often create infrastructure and web server farms that would then be handed over to application teams, and they would then go ahead and deploy applications on those standard static combinations of VMs and libraries and so on and so forth. And no longer is that the new reality, because of the democratization of application development that has taken place as a result of DevSecOps. So if we were to quickly review some of the key challenges that have come in the way of going ahead with cloud-first business strategy, one of the key problems has always been that the data that gets natively created in these SaaS and PaaS applications never actually makes its way. None of those transactions actually make their way to companies' existing network security infrastructure. Therefore creating blindfolds, therefore creating a visibility gap for traditional security teams. The idea of shared responsibility model poses good intent. But at the end of the day, if you look at it, a lot of responsibilities do fall on the shoulders of first customer, and not a whole lot of customers have the expertise in house, have the process investments in house to be able to take on hybrid cloud environments comprising a mix of private data center apps as well as apps that have been instantiated in the cloud. Obviously, given the fact that we are all going through pandemic, I can certainly share from experience, in the public sector space that I speak with, a lot of state local agencies on a day-to-day basis, and a lot of these agencies are dealing with the challenges posed by remote workforce. Employees accessing their cloud environments, accessing the state local government's cloud tenants from unmanaged devices. And in such scenarios, how would you go about controlling access to that data? How do you go about extending the controls on that uncensored data artifacts through their life cycle of not only just being created in the cloud, but also when they're getting downloaded onto those unmanaged devices? So quickly shifting gears to some of the key trends we've seen since the lockdown, particularly. Looking at the SaaS risk trends, there's been a massive influx of collaboration SaaS apps that have been used in 2020, thanks to the worlds of Zoom and Microsoft Teams that we live in today. There's been almost a 100% increase in cloud service access by unmanaged devices. We talked about that in the previous slide. And then about 1 in 4 cloud files have some semblance of censored data of one form or the other. The use cases that have come to light obviously have been, having the ability to prevent data loss and investigate malware in cloud service applications. The ability for companies to be able to do historical scans on structured components in applications like Salesforce, Workday, ServiceNow has obviously created a compliance driver for companies to implement data at rest scans in these cloud applications. Controlling, how personal devices can get synchronized to sanctioned cloud tenants like Box. There have been, the third point has actually been very interesting, where companies have started in, identifying what can be done to authorize, to validate the authorization profile maintained by an app that is hooked into an app marketplace. So as an example, if Alexa can read O365 calendar, how do you make sure that Alexa, as a third-party app, as a connected app to that app ecosystem, does not perform activities that are beyond its scope profile or beyond the authorization green that it has been granted? Looking at IaaS PaaS, these are trends that have mostly carried on from 2019. Cloud misconfigurations are obviously a big risky trend that we've been tracking at our end. There's been a massive increase in the number of attacks on cloud native accounts, cloud native administrative accounts, AWS keys, AWS credentials. There's been a massive number of attacks being launched by adversaries that are using cloud services for the purpose of crypto mining. And then the number of DLP incidents in IaaS obviously continues to surprise us because not a whole lot of companies are putting in the necessary proportionate security controls in the way they leverage S3 buckets and Azure blobs, and how containers often get access to such IaaS components as part of a running ecosystem. So some of the use cases tend to be, finding the ability to quickly detect and correct misconfigurations, the ability to secure workloads and containers, especially to, mitigate any vulnerabilities associated to container image related problems. And then obviously protecting data in cloud native apps, just because object storage can be misused by the likes of malware and by the likes of adversaries trying to siphon off data to external accounts. In terms of shadow applications, this is the 10% of the applications that I was talking about earlier in the presentation. Obviously, the number of cloud services used by the average enterprise continues to grow by leaps and bounds every day. So not all the cloud services that employees end up using actually meet the risk profile that has been set as a standard for third-party vendor assessment teams and so on and so forth. So a lot of times, employees end up using cloud applications without knowing the inadvertent risk they may be posing to the organization that they work for. So in such scenarios, obviously, some of the use cases tend to be, discovery of those shadow applications and the ability to govern their use so that people can be coached away from those high-risk apps towards sanctioned apps. And then applying conditional access controls and allowing tenant restriction type of controls so that somebody can access the corporate OneDrive environment, but not necessarily a personal OneDrive environment, right? So that is paramount so that data doesn't get siphoned off from a sanctioned cloud tenant to an unsanctioned cloud tenant that the corporate IT has no view of. And then obviously enforcing data loss preventions on sensitive data uploads that might be happening through the Pastebins or the Evernotes of the world that may not necessarily be in the purview of corporate IT. So finally, to bring the point home, cloud security is a complex topic. A few years ago, there weren't any, cross cloud service provider cloud security products available. So most of the enterprises relied on, native controls offered in each of the providers. And since most of us started with one, that wasn't really a problem. And the initial use was using a single SaaS app. Then the operational overhead was somewhat manageable. Then, as we took on newer SaaS applications and IaaS projects, sometimes, with multiple providers, we all found that, managing controls per cloud provider was kind of operationally impossible. The consistency was not there, having to deal with, 10 different terminologies for different cloud apps was just, a difficult task to build engineering processes around and to put security operations efforts around. So as a result of that, we are starting to see, technologies like CASB and architectures like SASE take off because this is the new paradigm that we are all moving towards, where there'll be multiple SaaS, multiple IaaS providers, and we've got to figure out a way to leverage controls that are outside of a given cloud provider or a service provider, as a matter of fact. Looking at the CASB market, the space has been well reviewed by analysts across the board for the last few years now. And if you look at the leaders quadrants across the board, you'll see McAfee, SkyHigh being the typical candidate there. So in terms of features, in terms of capabilities, in terms of keeping our customers happy, listening to them, and incorporating things into our product roadmaps, we've been doing a stellar job in maintaining that leadership across the board. So in this section, we'll be doing a high-level architecture review of MVISION Cloud. We'd start off with an overview of some top use cases, along with some architectural considerations that go along the way. As a reinforcement of the concepts we discussed earlier, CASB, like MVISION Cloud, offers a series of common security services, such as the ones listed out over here, across a wide variety of cloud applications. Some of the top use cases include, understanding, getting visibility and control around shadow IT usage. So that starts off with the discovery process, followed by a governance process on what kind of cloud applications are being used by a corporate workforce. And then that quickly, also results in other additional security controls, something along the lines of applying data loss prevention rules for data that gets created in the cloud, how that gets collaborated upon as and when it gets shared externally with other domains, the ability for a CASB to be able to block synchronization and download of sensitive data from corporate and sanctioned O365 tenants down to personal devices, By the way, that use case applies across other cloud services as well. Moving on here, some of the other use cases where CASB often provides a value is the ability for companies to get a full audit trail of user activities that might be taking place within a cloud service. Each cloud service provider has tens and thousands of activity events that get logged by their control plane. So we are able to collect all of that data from disparate cloud service providers. We are able to normalize all of those activity types, and then we are able to feed it all to our advanced threat protection engines, which basically are basing their judgment off of certain UEBA-based algorithms, which use both supervised and unsupervised machine learning to be able to detect compromised accounts, insider threats, and malware propagation events. Lastly, obviously, the security misconfiguration tends to be a high value use case for IaaS and PaaS services, but we are increasingly seeing the calls for misconfiguration violation or misconfiguration checks for SaaS services as well, of the likes of Office 365, Salesforce, and Box. So in terms of the architectural concepts, the way MVISION Cloud does what it does is via a combination of different modes. The most differentiating angle for MVISION Cloud versus the CASBs out in the marketplace is the strength of the platform in terms of its API connectivity with cloud service providers. So we basically establish an API connectivity with the customer's cloud tenant, and then based on OAuth 2 based authorization scopes, we are able to register the necessary event listeners, and we are able to on a per event basis get that activity feed so that we are able to understand what exactly has any given service principal performed in a given cloud service. And obviously the control, since it's an event-driven activity or a transaction-driven event, it's not a real-time capability. It caters to devices that could both be managed and unmanaged. It could be catering to people that may be part of your corporate workforce or part of your partner ecosystem, and the architectural mode works for applications that could be standard web apps or even cert-pinned apps. Right. The good thing about that is that there is no there's no impact to the user in terms of having to deploy any agents on the user's machine, or having to intermediate between the user accessing a cloud service via SSL inspection or other network plumbing that often comes into account with other modes. In tandem with that, there's the ability for us to be able to call synchronous APIs of certain cloud applications like Office 365 and Box. And via those synchronous events, we are able to get a hold of all the activities that pertain to collaboration happening in these cloud environments. So this is, since we are using synchronous APIs from Office 365, we are being able to effect real-time controls on when a collaboration event is happening on a sensitive data file happening in O365. That happens to be a platform differentiator for us, and oftentimes that's the #1 criteria that our customers love to implement, just because collaboration inherently is business enabling in one respect, but it's also it also poses a significant risk to sensitive data that sits out there in a cloud service. Moving on, in addition to the API mode connectivity, we also allow inline connectivity options, including the likes of a reverse proxy that basically can work as a SAML proxy. The idea here is that employees and third parties could be accessing these cloud applications from a variety of devices, and based on whether the device is a managed device or an unmanaged device, we can do that check in time, in real time, and based on the profile of that device, based on the health of the device, we can then continue to stay in line in that session by intercepting the SAML assertion generated on the device. The experience for the customer in this case continues to remain very smooth because we are not having to deploy any agents onto the machines that the users are accessing these cloud applications from, and all we are doing is basically intercepting the SAML assertion flow that is created between the identity provider and the service provider at the end of the day. Moving on, in terms of different mode, we also offer email DLP capabilities by either injecting ourselves into the email flow by being an SMTP proxy, or we can also use the native journaling capabilities offered by O365 and Gmail to be available in a passive mode to be able to inspect the content of email and their attachments as they're being sent out by the EOL or the Gmail servers, and then once we are able to pass the content inspection, or once we are able to study the violating content, we are then able to either pass the email back to these email servers, or we are able to write the email, the necessary X headers on those emails, so that these Exchange Online and Gmail servers can then pass those X headers over to the MTAs, the Message Transport Authority servers, to be able to block emails from ever being seen by the recipient. Finally, looking at the ground link or the shadow IT component of our product, we are able to ingest raw logs from companies, from enterprises' web proxy and firewall and SIM appliances, right? These are egress devices that often capture web transaction logs, web access logs for employees and for the remote workforce. And based on the parsing that we do locally of those raw logs, and based on the tokenization that we do locally in your premise of those logs, we're then able to generate or convert those logs into events that eventually populate the MVISION cloud service to help companies get the necessary visibility into shadow IT usage, and to help the companies control what shadow IT applications do get leveraged at the end of the day. Bringing the point home, this is basically just a reinforcement of the kind of concepts we talked about earlier. Things that basically start off in an implementation, start off here on the left-hand side, where after reviewing the logs, we are able to provide visibility and control around shadow IT usage, followed by API-based controls with sanctioned SaaS applications, which allow us to perform data loss prevention, collaboration control, and a fair amount of activity monitoring and UEBA type of security enforcement in these cloud applications. Along the way, for certain high-risk applications or certain high-risk vectors around cloud usage, we can also provide contextual access control on users and devices connecting to those cloud applications, while also layering on controls related to the email, etc. So now, pointing out to what we see on the right-hand side of this picture, this is in reference to some of the comments I made earlier with respect to McAfee's acquisition of SkyHigh. One of the, from a control perspective, one could also be deploying automated cloud governance via, some sort of like a cloud forward proxy. And in order to that would help companies block non-compliant and high-risk cloud applications, or maybe coach users to lower risk alternatives, alternative services with let's say splash pages and redirects. So one could also be enforcing data loss prevention rules on the DLP engine that comes native to a forward proxy. So a lot of these first mile controls require some sort of a web traffic redirection agent on the endpoints. The way this is accomplished with the McAfee product is via the use of McAfee client proxy agent. and that allows us to redirect any traffic over ports 8443 to the nearest cloud web proxy POP in a 5.9 SLA based manner. And then obviously we are then able to enforce the necessary policies in the closest POP associated to the device, such as being able to block certain activities, or being able to differentiate between personal versus corporate instances of a given cloud service, or also being able to inspect any kind of download operations happening on that managed device from the wild web. So this architecture hopefully rounds out the multi-mode CASB understanding that I called out earlier in the conversation. So let's move on to the next stage of our conversation. Finally, in the interest of time, we will largely be skipping through most of the constituents of the last section because I wanted to get to the demo section, as fast as possible. But if you were to go through the slides, you'll basically see a slide which calls out differences between what a cloud native application ecosystem looks like in comparison to traditional apps, and the idea of automation being central to enforcing good security hygiene in cloud native worlds. Then the next slide was to discuss, how enforcing good security hygiene is paramount early on in the SDLC lifecycle, because as we go towards the later phases of an SDLC lifecycle, the costs associated with injecting security, the costs associated with having the developer go back and review the work that they performed basically becomes intrinsically very expensive. Both in terms of cost and labor, and also in terms of the complexity that it may result in to remediate a given defect. And therefore, the marketing teams have always been championing the word shift left. But the idea of that is that instead of security configurations being studied after the fact the infrastructure has been deployed, it would be great if the security audit capabilities were to either be kicked off right after when the code is being built and tested, as in if there are any deployment templates or infrastructure as code templates that can be scanned on an on-demand basis. That's definitely a way to enforce security engineering in the earlier phases prior to things getting deployed. Or the best way to enforce security would ideally be when the code gets checked in some sort of like a source code repository like GitHub, GitLab, etc. This mechanism works off of a concept called pre-commit hook, so that once the code gets checked into a code repo, it automatically kicks off a scan, a configuration security posture management scan that is offered by the likes of a CASB platform. So the way we do that is by securing IaaS and PaaS components in these different cloud providers today. We are able to detect and correct security misconfigurations, detect and secure workloads and containers, and then protect the data in those apps by providing data loss prevention capabilities, as well as malware scan capabilities for blobs, stores, and Google storage buckets. So just giving you a high-level overview in terms of securing containers and orchestrators, there are a few security questions you've got to ask, which are to take into account that the containers are run by orchestrators with the right configuration settings, making sure that the containers do not end up using images that are not properly scanned in terms of vulnerability assessments, and then obviously offering security during all the phases of a container lifecycle, including while they're running. So the way MVISION Clouds assist our customers in layering those security controls is by providing the appropriate configuration security posture management checks for both container runtime and orchestrator system that basically end up instantiating the container clusters. We are also able to perform out of the box vulnerability scan checks on a container's manifest file to be able to completely build out a bill of material and to be able to map that across other components of a CV database. And then we are also able to, using the sidecar based model, we are also able to profile a given container's behavior while they are getting instantiated, so that we are then able to enforce immutability of those containers over time. This is just a summation of what I mentioned earlier. Basically, these capabilities exist in the product today, and I will, with that, I want to thank you for your time, and let's move on to the MVISION Cloud demo. MVISION Cloud is a cloud-based SaaS offering that's multi-tenant in nature, and there is a specific service tenant that's created for every customer, and the data pertaining to that customer then gets fully isolated or stays fully isolated to what's in their service tenant. The management UI, is based off of or basically fully leverages RBAC capabilities in the product, where individual roles can be assigned to different administrators, so that in this case you'd see a list of 150 odd people who have the ability to access this given dashboard, and some individuals have access to certain roles that allow them granular access to perform certain functions within MVISION Cloud. In conjunction with that, we also do offer the ability to segregate data. So where this comes handy is where we have environments, or customer environments, where there are multiple service instances of a given cloud service involved. So think about environments which might have multiple O365 tenants, or multiple AWS accounts, or multiple Azure subscriptions, right? So we could then limit an admin's access to the individual data components based on their attributes, such as what region they support at the end of the day, what department they support at the end of the day. We could do the same thing for sanctioned service jurisdictions as well, where based on their geolocation, we could then strictly limit their access to a given service instance of a cloud service. Then, if we go back to the dashboard offers a variety of executive dashboards or data points that can be all be distilled into executive reporting. It's based off of a card-based UX, where new cards can be added to supplement the analysis and insights from the overall platform. So if I were to show you the experience there, clicking on the card workflow, you could see that depending on the persona, individual data points can be added back to the dashboard. In the case of our hypothetical example, let's say if I'm interested to know about the volume of services of a certain category that were being accessed by my workforce, I could go here, select the Services tab, and basically go to one of the selected views or saved views. Or I could basically be creating a new dashboard card based on the data requirements that I have. But I could very well go down here and see something like allowed CRM type of apps that were used by my remote workforce or by my workforce in the last 7 days. And you could very well see that the analysis can be prepared, can be crystallized, and in a variety of visualizations, and we could obviously save this particular card to then have it get populated onto the main dashboard. So the extensibility of data points on the dashboard makes this a very flexible experience for our customers. And then you could then simply go down here and basically generate a business report or schedule a report to submit, to send that to your departmental heads and other folks. Next, moving on to some other aspects of the dashboard, such as the MITRE dashboard and the specific service related dashboards. This dashboard gives us a high-level overview of IaaS related environments. It helps us understand how many AWS, Azure, GCP resources we have, how many of them are compliant or non-compliant with the policy guardrails we put in place already, what those accounts, etc., tend to be, and how many resources are assigned to a given account, tracking compliance along the way, what kind of resource elements are the cause of the majority of configuration audit violations, what kind of policies are getting flagged, which basically should give you a pointed guidance in terms of what security control probably needs to get tightened and be shared across your development teams. You could see that there were certain security groups that were seen as unused. There were certain credit cards that were noted in one of the AWS S3 buckets, and so on and so forth. So there's a lot of powerful insight that can be gleaned based off of the IaaS dashboard. Next, we'll focus on something pretty cool, something very recent in the platform, which is called the dashboard, the MITRE ATT&CK dashboard, which basically maps all the different kinds of incident types, the incident families that pertain to MVISION Cloud, and it ties back those incident types. It ties back those incident types to individual techniques and procedures laid out in the MITRE ATT&CK matrix for cloud that was published late last year. So in this case, our incident types could be, could be as follows. You could have incident types that could be related to configuration audit violations. You could have incident types that may be related to malware being detected in one of your cloud environments. Those incident type violations could be related to data loss prevention kind of violations. Those violations could also be pertaining to apps hooked into your app marketplace. I believe we talked about that in one of the slides earlier. So depending on different incident families that are generated within MVISION Cloud, we then map these different incident types. We map these individual threats and anomalies that were picked up on by our UEB engine, and we then annotate them versus the MITRE ATT&CK framework. In this case, we, if I were to expand what was seen in the last 3 months, you could very well see that there were about 88 odd anomalies that were seen in the environment across the board, across the semblance of cloud services, and there were about 19 odd incidents that were seen in the environment. If I were to then distill my efforts further and perform additional due diligence, I could very well see exactly what kind of violations, what kind of incidents or anomalies were mapped back to an individual phase of the attack tool chain or attack chain. And over here, if I were to click on, let's say, transfer data from the cloud account, you could see that there was one anomaly that was flagged, which indicated that that sort of an operation did actually happen. In this case, if I were to click on service usage anomaly, it's basically saying that this particular fictitious admin basically performed a set of operations within Dropbox that were exceeding normal user behavior. So the UEB engine looked out for certain thresholds pertaining to a certain activity. In this case, the activity was download folder and files zip. And based on a threshold value, the UEB engine alerted the SOC admins, alerted the service owners that at least there was an anomalous event that was noticed pertaining to Dropbox. And since it's basically indicative of a download operation, it's been mapped back to this particular technique from MITRE, which is the transfer data from cloud. Some of the other techniques that were seen in the environment, you could see that there were 3 config audit violations that were seen in the environment, and what a SOC admin or what the triaging team can possibly implement to kind of mitigate the risk associated with uncommon ports. You could see that there were 2 resources that basically resulted in that violation. In this case, it was the ability for us to do an on-demand scan on Terraform templates. So we were able to catch some IAC infrastructure as code violations. We were able to flag that for the incident response team. Moving further, one of the other dashboards that should be looked at is the Cloud Security Advice dashboard. This dashboard provides a risk-based view to our customers to help them understand where they can be prioritizing their efforts in terms of visibility and control, and in terms of whether the steps that they're taking on a per quarter basis has helped them address risk effectively, and how effectively in relation to their peers. These are companies that map back to the same vertical, and therefore this kind of an analysis helps companies put into perspective whether they've got to focus further on visibility or whether they've got to focus more on control around cloud applications. And if we were to double down into each of these panes, we can see that the entire analysis is split between IaaS, Shadow IT, and SaaS services. So you can see that in this case, while the company's got a good game plan going in terms of some of these capabilities where data fingerprinting policy was enabled to perform structured and unstructured data match. There were there were controls put in place to review sensitive data across OneDrive and SharePoint sites. There could possibly be other steps taken to tighten up the collaboration game plan. And so in this case, while there were some collaboration rules that were put in place to protect OneDrive and SharePoint based documents, this particular company could be doing further or taking further steps to expand the collaboration policy to monitor shared links in Box, and same is the case with shared links in Teams. And from within these areas, you could basically click on this button, and it would take you straight to the DLP policy engine as well. So in short, the Cloud Security Advisor helps customers prioritize their efforts in the right direction, and also provides like a quantitative risk view on whether the efforts would help them mitigate risk actively or not. In the last few minutes, I'd like to touch on the policy incident experience. If I were to take your attention to the policy incident summary view, you can see that over the span of last 10 months, these were the kind of incidents that were seen in the environment. Those environments could then be further filtered down to the individual service level, or could be reviewed at from a severity perspective, or could be reviewed at based on any of these filter panel attributes here. You could also basically perform your due diligence based on the kind of incident violation that was seen in the environment, and you could also see the top defaulting policies that were in place to generate these incidents. This could help you either tighten up your DLP policies further. It could help you perform additional education in the environment to individual service owners and to individual users using those cloud services. And you could prioritize your efforts around how you would perform on-demand scans in the environment, and whether you've got to tighten up or change the scope associated to a given scan if it ends up generating too much noise. We've hardly spent any time on the policy engineering experience, but unfortunately we've kind of fallen out of time. There are a wide variety of policies that you can implement within MVISION Cloud. Let me just give you a high-level overview of what a sample DLP policy experience looks like. Going back to the overall problem definition of collaboration control, you can see that there are policies you can put in place that would not only help you detect sensitive data match, but it can also help you remediate collaboration control in real time. It can help you remediate or put together the appropriate guardrails to basically allow collaboration effectively, but to put some controls around the collaboration activity. So any DLP violation or any DLP policy could be mapped back to any of the modes that we were talking about earlier in the presentation. You could tie that policy back to a semblance of cloud applications if you wanted to. So you can see that this policy right now applies to OneDrive and SharePoint, but we could very well apply the policy to any of the cloud applications that are hooked up with the MVISION Cloud Tenant. You could point that policy and define it for certain users. You could define the appropriate DLP rule matching criteria. And since this is a collaboration-based rule, you can see that one of the rule set types we've enabled is to look for files and folders, and as long as they're they're being generated by any sender, and they're being indicative of a collaboration activity happening with any of these personal email accounts, personal email domains, regardless of the role, we basically map that rule matched criteria to a high severity rating. And if I were to go further down, this is where the response section is. You could basically say, for any of those high-risk matches, for any of those risky conditions met earlier, we'd like to block the collaboration from happening by default. There are other rule sets that you can expect from any DLP vendor out there in the marketplace. We can do classification-based matches where we can look for SharePoint tags. We can also do our due diligence based on file names and file paths. And if I were to click on this policy to be of a different mode, you can see that the number of options would definitely expand. So you could do data identifier based matches. You could do you could bring your own regexes here. You could point your DLP scan to a certain SharePoint site ID. You could also perform structured and unstructured data fingerprinting and so on and so forth. So the key thing to note here is that the collaboration rule set basically allows you to set up collaboration guardrails, and it also allows you to point your DLP policy to a specific Teams channel, or to a specific SharePoint site, or to a specific Slack channel if you needed to. With that, we have reached the end of a demo, and while there are lots of capabilities we did not get to talk about, this is an extensive platform with very comprehensive capabilities. I could spend the next 2 days talking to you about the product, but feel free to grab some time with me if you want to know more about the product in terms of how things are set up, in terms of how the capabilities get introduced into the environment. I'll be happy to share further details. So with that, thank you for your time, and talk to you soon.